Alrighty, welcome back to CIS 161, C++. Today we're going to be covering Chapter 4, but before we get into that chapter's content, I want to remind you, by way of review, kind of the lay of the land here as it stands on Canvas now that we've got a little content out there, not all of it, and I try not to enable stuff like ahead of time, so you won't see all chapters at all times. I'm going to reveal the content slowly, week by week, as we go by. But for now, if you go to Pages, remember this is kind of where the real meat is of the course. This is where you're going to find all the video lectures and any other kind of, I don't know, like mini lessons, I guess, that I'll publish here once, or if and when those needs arise. For example, of course, the Visual Studio setup was there first by way of introduction on getting your computer, your environment set up. Also, I have here a lecture collection page, which you guys can't see. If you find this valuable or think that it might be useful to you, I can turn this on for you guys. This is more or less like a catalog of all the lectures in one page. I just embed all the videos onto this page. Further, I've also managed to upload all these videos to a YouTube playlist on my own personal account. I'm not making those available as of yet, but if any of you feel that those would be useful, if you're somewhere out and about and you're just dying to listen to one of my lectures and you don't have access to Canvas or can't get to it for some reason, maybe YouTube is an easier avenue to get to the lesson, let me know and I'll go ahead and make a list of those public and available to you. Okay, so Chapter 4, Making Decisions. This is a pretty, I guess, meaty chapter. There's a lot going on here. It's a big deal. Here's kind of a list of topics. So we're going to start off with an overview of relational operators. So checking whether things are equal or how two values or two objects relate to each other. We're going to dive into the if statement, the if-else statement, and the if-else-if statement. Probably things you've seen in other classes or other programming languages. The syntax is more or less the same, and it should be stuff that you're used to seeing if you've used any other programming language or had any other classes in C++ before. We'll take a peek at menu-driven programs, nested if statements, logical operators. We're going to at least start the task of validating our user's input. Once we have if statements, we can start to say things and ask questions about the information that our users enter into our programs. So we've seen last chapter the cin operator. Well, we can check to see if a user's input falls within a given range. We can check to make sure it's a valid data type. And we can see if they've entered anything at all. We're going to get into more about block and scope. Remember, scope is the idea of what parts of your programs have access to what pieces of data. There's a little more info about characters and strings, conditional operator, the switch statement, and finally enumerated data types, or enums, or enumerations that go by many names. It's a bit of an advanced concept, but it's good to include here in the chapter on if statements. Diving right in, relational operators used to compare numeric and char values to determine the relative order. And if you've had even basic math classes, you've seen operators similar to these. We use a little bit different syntax in C++ and computer programming because we don't have access to, for example, in math, you see less than or equal to with like this, the less than symbol with a single horizontal line underneath it. There isn't that key on our keyboards, so instead we have the traditional greater than, less than, and you guys, if you're anything like me, probably have your own little kind of brain tricks for remembering which one of these operators is greater than, which one is less than. Use whatever tricks you need to kind of keep those straight in your head. When it comes to the greater than or equal to, less than or equal to, instead of, again, putting that horizontal line underneath the symbol, we simply place an equal sign to the right of the first operator, the first character. So this is greater than or equal to, less than or equal to. Double equal sign we're asking, is a thing equal to another thing? And we have to be very careful with the double equal sign and comparing things in this way, because we also have, as we've seen, a single equal sign, which is, of course, used for assignment. So as we go through the semester, I have my gripes, I guess, with how the developers or the designers of the C++ language chose to lay out their syntax. This is one of those complaints. Single equal sign and double equal sign look staggeringly similar, and they do radically different things. And in fact, if you're writing an if statement and you put a single equal sign instead of the double equal sign, it likely will compile, but you're going to have all sorts of runtime errors that are very, very difficult to debug. I know this from experience, and most students new to programming will make that mistake as well. They'll use a single equal sign when they meant to use a double equal sign, or vice versa. So we'll say more about that when the time comes. Not equal to, so exclamation point equal to. So this is asking, is thing A not equal to thing B? Exclamation point generally meaning not, or the negation operator. So these two you could think of as basically opposites of each other. Here's a few examples of this in action. Relational expressions are Boolean. In other words, they evaluate to true or false when the question is asked. And when you talk about relational expressions, you really are talking about asking a question. That's kind of how I think of it anyway. So as an example here, we're asking, is the number 12 greater than the number 5? Well, sure it is. So this in C++ would return the Boolean true. Is 7 less than or equal to 5? No, it is not. So that would return the Boolean false. If x is 10, then we can ask questions about x. So we're doing a little bit of variable substitution here. So anytime you see an x, treat that as the number 10. So we're saying, is 10 equal to 10? Yes, it is. That is a true statement. Is x less than or equal to 8? So is 10 less than or equal to 8? Absolutely not. And is x not equal to 8? That is true. 10 is not equal to 8. And is 10 equal to 8? That is false. And you can get really crazy with these Boolean expressions. If you're in some classes in basics, computer programming basics have entire assignments and tests and quizzes on these Boolean expressions. So you can ask questions like, is x equal to 10 and less than some number? You can definitely chain these together and make them as complex or as simple as you like and as you need. The thing to remember though is that they will always resolve, they will always evaluate to true or false. That's it. The value can be assigned to a variable like this, and I would consider this to be somewhat of an advanced syntax. This is, again, what I would consider like a shortcut to writing essentially an if statement. So if we have two variables, x and y, we have this variable called result. Remember, x and y are defined somewhere else. We're assuming those have values, say an integer value. We can say bool result is equal to, is x less than or equal to y? And the point of basically putting this example here is really to demonstrate the fact that these Boolean expressions evaluate to true or false. We have a bool variable called result, and it is equal to the question, is x less than or equal to y? And that happens to be a question that we can't answer. We don't know what the values of x and y are. But if x is, say, 10 and y is 20, 10 is less than or equal to 20. And so the value stored in result would be the Boolean true. Assign 0 for false, 1 for true. So this is another way of thinking about true and false, and deep down in a computer's hardware is how it thinks about true and false. That's how our CPU thinks about it. The CPU is made as efficient as it can be, so instead of using the word false and the word true, we'll just use a bit, 0 for false, 1 for true. Again here, do not confuse single equal sign which is assignment, and double equal sign, which is equal to. We'll get plenty of hands-on practice with this as we move along. There is, much like our arithmetic operators, there is technically a hierarchy of relational operators. This is what is done when evaluating an expression that contains multiple relational operators. It happens to be that greater than or equal to, less than or equal to, has a higher precedence than these guys. Is equal to and not equal to. I have never needed to commit this hierarchy to memory in any programming that I've done ever. And that is because if you're finding yourself in this situation where you're not sure whether greater than or equal to is going to be evaluated before not equal to, if you were ever in that situation, you can probably guess what I'm going to say. Just use a set of parens. Why leave it to chance? Why leave it to our feeble memories as far as what is the precedence of these operators? Don't leave it to chance or your feeble mind, my feeble mind. I would just use parentheses. That way you'll know for sure, which is going to be evaluated first. And you can control it. You're not leaving it up to C++ internals to figure out which goes first. Enough slides, let's get into a hands-on. Page 160, fire up our trusty digital textbook. Here's that table of the relational operators. And let's dive into our first hands-on of Chapter 4. Program 4-1. So again, I will take you through yet another review of how to set up your project's folder structure for the entire semester per chapter. Create a new project. Create a new console app. Chapter 4 is my solution name. My project name, though, is EX 4-1. And this is what I was talking about before with, like, I wish they would put the solution name first, because the solution name is a higher level sort of structure than the project name. So this is what's going to be Chapter 4. You can see the path of your project. For me, it's C users Kevin source repos, Chapter 4, EX 4-1. And remember, we're not going to check place solution and project in the same directory. I heard one time that in some of the other programming classes, this checkbox is checked, and for good reason. In the introductory course, it probably keeps the folder structure much more simplified if you do keep all this stuff kind of in one folder. But for us, since we have so many sub-projects in our solutions, we're not going to do that. Go ahead and create it. And here we go. Let me get my screen formatted a little bit better here. Excellent. Okay, so with everything that we just talked about in the PowerPoint slides, there's nothing extra we need to include, no additional namespaces that we need. These are things that are built into the C++ core language. So we're going to create some booleans, some bools, true value, false value. We're going to create some integers, x, set it equal to 5 right off the bat, and y is equal to 10. Here we're going to assign true value to the expression is x less than y. False value is going to be equal to is y equal to x. And we can print it. True value is And hopefully, as you're typing, you can predict the result. So is 5 less than 10? Yes, it is. Hence the name of the variable, true value. Is 5 equal to 10? No, it is not. Hence the name of the variable, false value. We've predicted the output. Let's see if we guessed correctly. We did. Maybe our assumption about how those were going to be printed out, maybe that wasn't so, I guess, correct. So under the hood, even though we have the keywords true and false, the computer is showing us 1 for true, 0 for false. That's what we get when we print out the value of a Boolean to standard output. And you can see down here, true is set to 1, false is set to 0. Hopefully you've noticed this by now. We've pointed it out before. If you don't feel like going through and typing out every single example, I hope that you do that for at least 80 to 90% of them. But if your little fingers are getting too tired, you can always just look here and see what a sample output is for a given example. Cool. With that out of the way, we can dive into the if statement, and there's a very good reason why we had to cover conditional expressions before covering the if statement. Conditional expressions are definitely a huge part of the if statement. You're asking a question with an if statement, and the conditional expression is the question that you're asking. So the if statement, broadly speaking, supports the use of a decision structure giving a program more than one path of execution. With all of our programs so far, we started executing the program at the top and we went down line by line, no deviation. Every line was executed. There is no branching. There is nothing. Allows statements to be continually or conditionally executed or skipped over. Models the way we evaluate real life situations. For example, if it is cold outside, wear a coat and wear a hat. Sometimes these are referred to as if-then statements. In other languages, like I think Visual Basic, if you use an if statement, if you use the if keyword, you have to follow it up with a corresponding then statement. So in a language like Visual Basic, you would say, if it is cold outside, then wear a coat and wear a hat. In C++, we don't really have the then keyword. We just assume whatever comes after the if statement is the then. And as we'll see, actually in the next slide, we'll just go there. The then is basically what is contained in the opening and closing curly brackets. So here's the general format. We start with the keyword if, followed by our condition, and that's going to be one of those Boolean expressions that we talked about earlier. No semicolon, that's a good note. No semicolon after the closing paren of our if statement. Then we have opening curly brace, closing curly brace, and everything in between is what executes if this condition is true. And we call this the body of the if statement. So this is what gets executed or run if your condition evaluates to true. It's always if it is true. If this condition turns out to be false, whatever it is, this will be skipped over. Notice that inside of the body of the if statement, we have semicolons at the end of all of our statements. So those do utilize semicolons. Those are just going to be lines of code like we've seen. Could be variable declaration and assignment, could be cout statements, could be other if statements, a variety of things. I'm just reading here, the block of statements inside the braces is called the body of the if statement. Here's an important point. If there is only one statement in the body of the if statement, there's only one statement in the body, then the curly braces may be omitted or left out. I'll show you what that looks like in a minute. I don't recommend this, specifically for new programmers. That's just one extra thing you have to keep in mind when you're trying to learn a new language like C++. I would say, if I was you, I would skip over this. I would forget this even exists. But I am going to show it to you because you may see it out in the wild, and I want you to be comfortable with the lack of curly braces. Okay. If the condition is true, then the statements, so it could be one or many statements, inside of the body, inside of the curly braces are executed. If it is false, then the statements are skipped. For those of you who just love flowcharting, here's what a typical, traditional flowchart would look like for a condition. A condition is usually represented by a diamond shape in your flowchart, and it's good for facilitating the branching nature of this. So if the condition is false, then we go around basically the statements that get executed if the condition is true. So coming into the if statement, we have some condition. If it is true, execute the statements, continue on with the program. If it is false, we branch over this way and skip over all those statements that would have been executed had the condition been true. Finally, some actual code here before we get our hands on. This is good. Example if statements. So if some variable defined above called score is greater than or equal to 60, cout you passed. Okay. Obviously, this is an example of an if statement that has a body of only one statement that has the parens omitted. So don't be freaked out if you see this out in the wild, where you're like, okay, if statement, then hey, where's my curlies? Just assume that the very next statement that occurs after your if is basically the then. That's the body of the if. Again, I do not recommend this. Let's see if I can write code in PowerPoint. I would say just always do that. There's nothing wrong with that. As you get more comfortable with the language and just programming in general, if you want to go ahead and skip the curly braces, I'm okay with that. There's even a good reason to do something like this. I have code in the wild, or I have if statements. It doesn't look very good here, but actually I have the if condition and then the statement all on the same line. Of course, we have text wrapping here, so maybe we can just look something like this. This is good if you just need a quick check. If there's a quick if statement followed by a very, very simple statement right after it, you can go ahead and inline that whole bad boy in a single line of code. Again, don't recommend that for you, but if you see it, hopefully it won't take you by surprise. Okay, then we have kind of a more normal syntax here. If score is greater than or equal to 90, some variable called grade, which happens to be a char, is equal to the letter A. Print out a statement, and that's the end of your if. Notice again, no semicolon here. This is bad. I don't even think this will cause a compile error. If you added a semicolon here, this would just basically, if I remember correctly, just causes the if statement to be basically skipped over entirely. No semicolon. And yeah, that's your basic if statement. Let's get a hands-on example on page 165. Remember, I'm skipping over pages in the textbook. I'm giving you high points, high-level summaries through the PowerPoint presentations. You, however, of course, should be reading the chapter. Example 4-2. If you check out the listing, the code listing from the textbook, we do have an additional include. IOMNIP. Think about it for a second. See if you can remember what the purpose of the IOMNIP include is. And there's a good clue in the name of it itself. So IO, input, output, manip, you can assume manipulation. So this is going to help us control the formatting of our output using our cout statements. So let's create some integers here. Score 1, score 2, score 3. all integers, and a double called average. Cout, enter 3 test scores, and I will average them. Classic textbook example for an introductory programming course. All right, let's see in score 1. We're going to use that shorthand syntax that's kind of gross. Yeah, there we go. Okay, we've got our double average. So average, we're going to assign, remember single equal sign is assignment, score 1, score 2 plus score 3, all divided by 3.0. Couple words about this calculation. Parens are important here. If I had left off the set of parens, then order of operations would dictate that score 3 would get divided by 3.0 first, and then score 1 and 2 would be added to that result. We know that that is not how you calculate the average. We sum score 1, score 2, score 3, and then divide by the total number of scores, which in this case is 3. You might be wondering, why is it 3.0 and not 3? Think about your data types. Score 1, score 2, and score 3 are all integers. They're all whole numbers, but it's very unlikely that the average is going to be a whole number. So average itself is a double, but if we're summing 3 ints and then dividing by an int, we're going to get some imprecise results back. So we're basically forcing this to do fractional division and give us the result in our average variable. Okay, let's see out. We're going to basically convert ourselves to fixed output formatting here. Show point set precision to 1. Yes, the syntax is kind of wonky. Cout your average is, print that out. Now we can do some testing on our average. If average equals 100, cout grats. That's a perfect score. There. Okay, let's test it out. And I guess one kind of good idea to verify that you've typed in your code correctly, you may not have any compile errors, but to verify that you don't have any logic errors either, when you go ahead and run these examples, I guess I would recommend testing it a couple times with the input that's given in the code listing in the textbook. So in this example, they have 80, 90, and not 700, but 70. And then the average is 80.0. And that does match up with what they have in the textbook. Could do this again. Try the second example, which they have all 100s. Average is 100. Okay, great. Our input matches their output. And our output, wait, I said that wrong. Our values match. All right, now let's use our own. Maybe we'll get a not so nice result here. 22.3. And that 0.3, remember, comes from that set precision 1. So our output is looking good. And yeah, you could check that on a calculator to make sure that that average is what we would expect it to be. Okay, some notes on the if statement. Obviously, if is a keyword and must be lowercase. You cannot use it in a variable name or anything defined by you. The condition must be enclosed in parens. There are some languages, like Python, that make the parens optional. You don't have to include the parens in an if statement in Python. I generally do, but some people don't. You do not place a semicolon after the condition itself. Don't forget the curly braces, and don't confuse single assignment with double assignment. Style recommendations on the if statement. Pretty commonsensical stuff here. So place each statement, semicolon, on a separate line after the condition. Indent each statement in the body. When using open close parens around the body, put them on lines by themselves. What that means is, and maybe you noticed it when I was even typing here, out in the wild, you're probably going to see curly braces written like this, and I've mentioned it before, but rears its head again. Where the opening curly is on the same line as the if statement of the condition. There's nothing wrong with that. It saves a line. But for our sake, I think we're going to keep our code formatted like this. This happens to be the style recommendation of the textbook, but not a technical requirement. Okay, what is true and what is false? It sounds like a slide you would see in a philosophy class. An expression whose value is 0 is considered false, and if it's non-zero, it's considered true. So pay attention there, that's kind of subtle. If it's 0, it's false. That kind of makes sense. It's kind of a no-brainer, but check it out here. We might expect to see whose value is 1 is considered true, but that's not what this says. This says if a value is non-zero, it's considered to be true. An expression need not be a comparison. It can be a single variable or a mathematical expression. So, in other words, it doesn't always have to look like this. You could have a simple Boolean in here. Let's actually try it. Let's substitute that out. Programming on the fly here, coming up with my own examples. So just to give you another taste of this, another flavor of what this could look like, we could have bool. Just call it is 100. How about is average 100 is equal to the expression average is equal to 100. And now we've kind of outsourced this up here and stored the result of this expression inside of this variable. So now we can just do a simple substitution. Is average, if I can type on my little keyboard here, is average 100, and we should get the same output. Let's verify. If we do 80, 90, 70, great. Same thing. So totally up to you. You typically, if I would have to say one way or another, you probably wouldn't see it written like this. You would probably more than likely see average equal to 100 inside of the if itself. But just to, like I say, give you another flavor for what this could look like, you could do something like this. And that's what the slide is getting at. An expression need not be a comparison. It can be a single variable, which is what we did. However, the important thing to remember is that this is still a true or false statement. Asking the question, is average equal to 100? That's a true or false statement. It is either true or false. However, so is this. Is average 100 is also a true or false statement. In this case, it happens to be, well, whatever the input is divided by 3. Okay? When talking about conditionals, there is a kind of a key term in the industry in programming called a flag, or a flag variable. It is a variable that signals a condition, usually implemented as a bool. If the flag is true, that means the condition exists. If it is false, that means the condition does not exist. The flag can be both set and tested with if statements. Here's an example. Valid months is a flag. So we're creating a Boolean called valid months, assigning it equal to true. And a lot of times in languages, in programming languages, you will see a convention sort of like this, where the name of the variable itself will give you a hint about whether or not it's a Boolean. So if a variable name starts with the word is valid months, that's kind of your signal to maybe assume that this is a Boolean variable. Is valid months, I'll convert it back since that's what we're seeing on the slide. Boolean valid months equals true. If months is less than 0, valid months is false. And then if valid months, monthly payment equals total divided by months. So kind of an arbitrary example here, but what it's getting at is a little bit of input validation. So say the user has to enter some number of months stored in a months variable. If months is less than 0, that's basically invalid input. You can't have a number of months less than 0. So we're going to set this little flag variable to false. Down here, we're going to check to see, have they entered a valid value for months? If so, go ahead and run some calculation. Otherwise, just skip over it. Integer variables can be used as flags. Doesn't always have to be a true or false. Well, let's keep going. Remember that 0 means false or anything else means true. So here's an example of this. An integer variable called all done equals 0. In other words, it's false. So if some variable count is greater than some constant called max students, set the variable all done equal to 1. And that basically sets it to true. Now you don't have to set it to 1. If you remember, any non-zero number here will mean it is true. So you could set it to that, whatever that means, and all done is treated as true. And in the if statement, again, if it's anything other than 0, that means this is true, and whatever task has been finished. Okay, extending on the if statement a little bit, the if-else statements allows a choice between statements, depending on whether the condition is true or false. So the format looks like this, and in our program, this is basically treated as one logical sort of chunk, one logical piece of code. So if some condition is true, do this. Otherwise, if this is not true, if this is false, then do this set of statements. So in the previous examples, we basically said if some condition is true, then do a thing, and then just keep on executing. Here we're saying if this is true, do a thing, otherwise do this other thing. Oh, I see a flow chart coming up. All right, hands on page 173. This will be example 4-3. Okay. Int number, cout, enter an int. And I'll tell you if it's odd or even. Cn to number. Okay, so here's a little math trick on how to check if a value is odd or even. So if our number that we entered modulus 2 is equal to 0. One of the few actual useful cases for the modulus operator. So if we take whatever number we enter and divide it by 2 and the remainder is 0, that means that the number we entered is even. So for example, if I enter the number 8, I divide 8 by 2, the remainder of that is 0. 8 divided by 2 is an even number. Otherwise, it's going to be some fraction, and that's going to mean that the number is odd. Now I'm going to show you a few different ways to write this. So cout number is even is odd. Okay, let's just test this out to make sure it works, and then I'll show you a couple of variations of it. So following with the book, so 17. Whoop, I did not activate this new program. I'll do that now. Enter an int, so 17 is odd. 90 is even. Okay, great. Check this out. So they've taken the approach in this example of omitting the curly braces because there's only one statement inside of the if and inside of the else. In Visual Studio, there's a quick way to wrap a set of statements with curly braces, and that way is to highlight the statement or statements that you want to wrap, hold Shift, and press, well, just create a curly brace. That'll auto wrap it. Saves you a little bit of time with formatting that thing, so select the lines, hit the opening curly brace key, and it'll wrap it. So if you guys wrote yours this way, that's totally fine, totally valid. And I would actually recommend it for new programmers. Now also, you could do it like this. And honestly, if you're out in the wild looking at code, looking at other people's code, this is probably what you'd see. You would see all of this basically on a single line. And you could even line it up so it looks nice. So if that number mod 2 equals 0, it's even, otherwise it's odd. Just kind of formats everything nicely on single lines. Would not recommend this method for you guys. All right, that's the if-else. Here's the flow. Very, very similar to the other flow chart. So we come into our condition, we ask a question, we evaluate our condition. If it is false, do this set of statements. If it is true, do this set of statements, and regardless, come back together and execute down the program. So how the if-else works, if condition is true, statement set 1 is executed and statement set 2 is skipped. So obviously, if we're going down this side of the branch, we're skipping over this side of the branch. And if we're going down this side, then this side is skipped over. Kind of a no-brainer. If condition is false, statement set 1 is skipped, and then statement set 2 is executed. So another example, again with the if-else. So we have if score is greater than 60, you passed. Otherwise or else, you did not pass. If interest rate is greater than 0, interest equals some calculation and then cout the interest rate, or the interest itself. Else, cout you owe no interest. Notice how they've omitted the curlies here, because there is just a single statement, and they've included them here, albeit poorly. I would never do something like this. I suspect it's just to keep it all in one slide there. But it is valid syntax. You could use a set of curlies on the if and skip them in the else, and that would compile just fine. So if versus if else. So if there are two conditions and both of them can be true or both can be false, then use two if statements. This is pretty subtle. We'll try to kind of parse it out as best we can. So if num is greater than 0, cout num is positive. If num mod 2 is 0, print that it's even. So these are like two separate ideas. We want to run both of these ifs. With our even odd check, we ran one or the other. We ran the if or the else, never both. But if there are truly two checks that you need to do and run them both, you would use two sets of if statements. And really the only way to the only rule of thumb, I guess, with the if else, do I use if else or do I use two if statements, is just by the nature of the problem you're trying to solve. If you know you need to ask two questions every time, then two ifs is going to be what you go with. If something is an if or something else, then it's an if-else. Let's dive into a hands-on page 174. Example 4-4. Okay, 3 double variables, num1, num2, and quotient. Cout, enter 2 numbers, cin, num1, num2. Okay, doing some checking here. So if num2 is not equal to 0, quotient, spelling test here, equals num1 divided by num2, and then see out something. So we'll just print out what it is. So quotient is like so. So we're basically just doing a division, and it's actually quite a useful example. Else cout error. Division by 0 is not possible. Any basic math class will tell you that. Return 0. Let's try it. Enter 2 number. How about numbers? How about 10 and 0? Error, division by 0 is not possible. What we did is we caught that error. What I'm going to do is comment out some stuff that checks for that. Run it and see what would happen if we didn't check for that. So 10, nothing. Do we get any errors down here? Error list. Oop, not Test Explorer. Uh, 10 divided by 0. That failed more gracefully than I thought it would. Let's try another run. Quotient is 5. Oh, right. Because we have the if in there. Obviously, we're still checking for it. We're just not displaying anything. If it happens, we need to do a little more commenting. Like this. 10, 0. There you go. Quotient is infinity. So C++ has chosen to not necessarily crash out on us. The program didn't crash. Instead, they've just defined as a divide by 0 error is going to be equal to infinity. All right, fine. At least it didn't crash. But we would certainly prefer to check for that more gracefully than seeing infinity printed out. And that's what we're doing here. Cool. Here we go. Comparisons with floating point numbers. Yes, it is difficult to test for equality when working with floating point. It's better to use greater than or less than tests, or test to see if the value is very close to a given value. Good example here. Page 175. Right here. Yes, this gets a little sticky. EX 4-5. Okay. Let's create a double variable called result and equal, set it equal to point. How many sixes is that? 1, 2, 5. 1, 2, 3, 4, 5, and a 7. Times 6.0. So just doing some math. Cout result is result. So 2/3 of 6 should be 4. So what we're trying to do here is simulate. I'll put that in a comment. Like, what is 2/3 of 6? As the comment here says, 2/3 of 6 should be 4. If you print the result, 4 is displayed. So it should be printed. However, if we do an if statement where result is our condition and we compare it with 4, this has screwed me up so many times in the real world. In my code that I work on day to day, we do have quite a bit of math involved. And anytime you have math involved, you deal with precision. And if you have to ask questions about those precision variables, then that's a recipe for disaster. So here we're going to check to see if result is 4, cout result does equal 4. Else cout does not equal 4. Let's see if there's anything else. Probably not. Just a return. Result does not equal 4, so what gives? Like, okay, let's trace this through. Here's the calculation, basically 2/3 times 6. According to this cout statement, the result is 4. But down here, when we're checking for comparison, result does not equal 4. So what gives? Well, let me jump back a page. The comment says, internally, the result is not precisely equal to 4. What it probably is 4.00000001 or something like that. It's just something we have to deal with under the hood when we're writing comparisons with doubles. From the textbook, typically the value in result will be a number just short of 4, or that. So it could be just short of or slightly greater than, like I was saying. To prevent errors like this, it is wise to stick with greater than, less than comparisons when using floating point. For example, instead of testing the result equal to 4, you can see if it's very close to 4, and you can see what that looks like here. Let's just rewrite this one. Okay, where does this change? So changes in the if statement. So if, and they also have included CMath. Include CMath. Now that we've included CMath, we can use ABS, or absolute value. If the absolute value of result minus 4 is less than 0.0001, the result does equal 4, so we're going to treat that as 4. What have I done wrong? Too many parens? Yes. So take the absolute value of the result, which we kind of think maybe is 4, minus 4. If that is less than this very small number, we'll consider that to be equal 4. I think this is called the discriminator value, but I'm not positive. Don't quote me on that one. So hopefully you can follow that logic. If the result of this, the absolute value of it, so if it happens to be negative, flip it positive. Check to see if it's smaller than this very small number. If it is, it's close enough, and we'll say it does equal 4. Cool. Very, very subtle idea there. Okay. Moving right along here. So far we've basically seen, flip back to this flowchart, two possible branches. So if a thing is true, do this. Otherwise, do this set of statements and continue on. But in reality, we can have as many branching paths as we need. So the if, else, if statement. So we had the if, else statement. Now we have the if, else, if. So it's a chain of if statements that test in order until one is found to be true. They are also trying to model like a thought process, such as, if it is raining, take an umbrella. Otherwise, if it's windy, take a hat. Otherwise, if it is sunny, take sunglasses. You could also write this one step further. Else, don't know how hot it is, or don't know what the weather is. So if it's raining, take an umbrella. If it's windy, take a hat. Else, if it's sunny, take sunglasses. Else, don't know what the weather is. So this is like the default condition. If none of these other things are true, notice these are truth statements. It is raining, true or false. It is windy, true or false. It is sunny, true or false. If all of these are false when testing the weather, then we just say, I don't know what the weather is. In flowchart form, it might look like this. If condition 1, do the set of statements here. Else, if condition true, notice the space between the else and the if. Different languages format this differently, like some strange languages use elif. I think Python uses elif. And we can have as many else ifs as we like. Notice condition 1, statement set 1, condition 2, statement set 2, condition n, statement set n. So we kind of run down the list of if, else, ifs and see if any of them are true. The first one that is true, we run those set of statements, and then we exit the if, else branch. Let's do a hands-on, couple of them. See if we can make some more sense of this. Page 178. Okay. Oop, not that. Cool. Okay, good. Here's some review of our const keyword. So const int min a score with our const sort of name formatting here, all capitalized letters and underscores in between words, 90. And here they're trying to be clever about how they format this. So we're creating several const ints at once. Min b score equals 80. Like so. Int test score, char grade. Probably guess where we're going with this. This is a pretty classic example of how to demonstrate these long chains of if, else, if. Cout, enter your test score to get a grade. Cn test score if test score is greater than or equal to min A score. Grade equals the character A. Else if test score greater than or equal to min B score, grade equals B. Min C score and sometimes if I know I'm dealing with a lot of these, I'll go ahead and just write out all the conditions, all the else ifs. Min D score, and I will point out we don't have a min F score for hopefully obvious reasons. Else, like so, grade equals C. Else grade is the character F. Okay, before we go and talk about all that, let's print out the result. Your grade is that. Okay, let's collapse all these. Make 4.7 our startup project. Enter your test score. So let's try a 90. Got an A. Let's try, what's our min C score? So 70 is our min C score. So let's try 69. Got a D. Let's try an F. I don't know. How about, let's try a couple things for our F. Let's try like, I don't know, 13 or 24, sure. Got an F. No surprise there. That's a bad score. What if I get a 0? Grade is an F. Or, what if I get a -1? Obviously, grade is an F. So, let's take a look at this from top down. So we've got all these constants defined, and we could say, we could get around using constants here. We could just say 90 here instead of min A score, B score, etc. But this is really nice because if we come in later and we need to change our grading scheme to grade on a curve or something, we have this nice little library of consts up here that we can reference kind of all in one spot. So if I need to change my grading threshold slightly, I can just do it up here instead of having to hunt for it all throughout my program. So that's the rationale for using these consts. So now we're checking to see, is my grade, here's my test, greater than or equal to 90? If it is, assign the letter A to grade and skip the rest of this. That's the important thing about if, else, if. If one of these becomes true, we execute the statements there and then skip over the rest of the structure. Now, if you came down here and wrote if, blah, 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 else if, blah, blah, blah. This is its own separate structure. Okay, these would execute just like the if, else if up here. So it's treated as its own if, else if structure. Okay, so if we find one of these that's true, execute the statements, and then break out of the else if structure. If none of these are true, if my score isn't greater than or equal to 90, if I come down here, my score is not greater than or equal to 80, 70, it's not greater than or equal to 60. If it's none of those, we failed. We get an F. But we could introduce some more logic here. We could say, like they have it in the textbook, else if. We could check for 0 and assign F. Else, I don't know. What do you do if you have a negative test score? We could say grade equals X. I don't know. Some letter that indicates that there was a problem. Okay, that's up to you. Maybe you leave it blank or make it a space. I don't know. Okay, so that's the if, else, if structure. You can go on and on with else ifs as long as you need. Let's see what the next one is, page 181. Here's a nice flowchart of that code we just wrote. Independent if assigned letter grade. One sec here. Yeah. Let's do this. I forgot I wanted to show you a quick formatting thing here too. This example actually is a really good example or use case for doing something like this. You really save a lot of space if you keep all these nice and aligned. Out in the wild, you probably would see code written like this for this specific case. No open closing curlies, not even a new line. Just being as efficient as possible with the spacing and the formatting of our code. Okay. Good. I'm going to undo all that. Sure, we'll make it an X semicolon. Okay, 4-8, let's see what they're getting at here. Illustrates a bug that occurs when independent if-else statements are used to assign a letter grade to a numeric test score. Create named constants, we got that. Int test score, char grade, good. Enter your numeric test score, and I will tell you the letter grade, cn test score greater than or equal to min a score. Yes. I'm not going to code this up. I'm just going to point out the difference here. So check out what they've done differently. We have if, else if, all the way down to our else. Here they have separate if statements. So where, in our case, if any of these becomes true, the rest below is skipped over. In this case, if one of them is true, we're going to assign the letter grade A and move right along because we didn't say else if, we said if. So we start a new if, else if structure here. Each of these is its own independent if, else, if structure. So if our score is like they have in the result, if we have 88, sure. If we score an 88, 88 is not greater than or equal to 90, so we're going to skip over that. 88 is greater than or equal to 80, so grade is going to be B. Then we're going to go down here, since this is if and not else if, 88 is greater than or equal to 70. So now my grade is a C. It's not an else if, so I'm going to check this one too. It's greater than or equal to 60. Now my grade's a D. Holy cow. Now I'm seeing, is my test score 88 greater than or equal to 0? Yes, it is, so I get an F. Bummer. Okay. A catastrophic bug in our grading program. All because we didn't use else if. We used straight up if. Okay. Okay, we already tried this using a trailing else. It's getting late. Is used with a set of if, else, if statements. It provides a default statement or action that is performed when none of the conditions is true. It can be used to catch invalid values. That's a really, really good use case, or handle other exceptional situations. I'm not going to do an example of this specifically since we've already kind of seen it. But let's check out this sort of age validator. So example of if else with a trailing else, which is what we've again already seen. So we're going to enter into this if else if structure and check to see if age is greater than or equal to 21 If it is, we're going to print out adult. If it's greater than or equal to 13, teenager. Greater than or equal to 2, child. Otherwise, I guess we'll assume that they're a baby. So they're not greater than or equal to 2, which means they're less than 2, basically. 0 to 2. We'll go ahead and skip that example. Menu-driven programming. That's kind of the gist of if, else if, and else. We're going to be using a lot of examples of those throughout the entire semester. It is like a core feature to any good programming language, the ability to make decisions and branch off in various directions in our code. So what is a menu-driven program? Shifting gears a little bit. So a menu is a list of choices presented to the user on the computer screen. A menu-driven program is a program where its execution is controlled by a user selecting from a list of actions. A menu-driven program can be written using if, else if statements. How do we organize this thing? Let me take a drink and I'll tell you. So we display a list of numbered or lettered choices for actions. Input user selection of the number or letter. We test the selection in a condition. If it's a match, then we execute the code to carry out the desired action. If it's not, then we test the next condition. Let's see what I mean by that on page 185. Here's a good example just from the textbook. So a menu could look something like this. If you're a gamer, you're probably familiar with like a settings menu, similar idea, only instead of selecting a menu option with our controller, we're selecting it with a number or a letter on the keyboard. So here's a menu. We could add a name to a list, remove a name, change a name, print the list, or quit the program. Let's check out listing 4-10. We're going to include iomanip here. Create some consts. Adult rate equals 120.0, whatever that means. We're not sure yet. Const double child rate 60.0. Const double senior rate equals 100.0. Now I want to point out something here. In the book, you can see in their listing, they have it nice and aligned. There's nothing wrong with adding an extra space here. We're used to seeing a single space between the name of the variable or constant and the equal sign. There's nothing wrong with adding additional white space. It's kind of nice to see it all nicely aligned. And in fact, they've done it again here so that all of our decimal points are aligned. Hundreds, tens, and ones places are all aligned as well. Like I say, the decimal point and then the 0 at the end too. Okay. Let's add some more data. Int choice. Now, just because it's our first example of this, I'll go ahead and kind of type out all the details of our menu here. Health club membership menu. Just some graphical interface design here, which I am horrible at. Now we'll print out the menu choices for the user. So 1, we'll keep these somewhat aligned. Standard adult. Cout child. I'm going to abbreviate this somewhat. You get the idea. Cout 3 senior 4 quit and cout a prompt. Enter your choice. cin to choice. Okay, we're accepting input from the user and storing it in the variable called choice, and it happens to be an integer. Okay, now we're going to enter into our, whoop, no we're not. We're going to set some options here. We're going to see out that we want fixed formatting, show point, and set precision of 2 decimal points. And remember, we're see-outing this, but we're not actually really seeing anything. These statements are more like setting options for how our output is to be displayed from here on out, from here on forward. Keep that in mind. Now we're going to use menu-driven development to pick which function we should run. So if my choice is equal to 1, I'm going to do this. Give us some more room here. There we go. See out for how many months. We're going to see into months. Set charges equal to months times adult rate. Since this is choice 1, you can see it matches up. Standard adult, if choice is 1, we're going to multiply it by the adult rate. See out total charges are $ charges endl. Now because I'm somewhat lazy, I will copy paste. Else, if choice is 2, we're still going to use the same prompt. There's a better way to do this. This is a little bit redundant because we're saying the same thing more than once. In other words, you're going to see that for each choice, we're going to prompt for how many months. The calculation is more or less going to be the same, except our rate is going to be changed. So keep that in the back of your head. Anytime, I will say this, just a general rule. Anytime in your code you're starting to see the exact same line of code showing up, I would say really 3 or more times. I wouldn't be so drastic as to say 2 or more. I would really say 3 or more times. There's probably room for optimization. That usually means that you can do something a little bit better in your code, whatever that means. Using an extra function, generalizing something, you can do something a little bit better. We're not quite there yet in this stage of the course, so we're okay with a little bit of redundancy, but just start to notice that when you see the same lines of code showing up more than once, more than twice, probably something can be done to optimize this. Now, another word of caution here, if you're copying and pasting, it's great for lazy typers like me, but it's also error prone. So I have to remember to change the 1 to a 2. I still ask for how many months, C into months, charges equals months times child rate. Charges are, that prompt is the same as well. Okay? For how many months, that is the same. Input into months. Now we're getting the senior rate. Now red flag should be going off in your mind. A lot of this is the same. Really the only thing that's different is the charges line. Okay? Moving on, do we have F4? Yeah, okay. So we've checked to see if it's 1, or if it's 2, or if it's 3, we're doing stuff. Else if choice, this is clever actually, if choice is not equal to 4, see out invalid input. Choices are 1 through 4. We'll start a new line, maybe. Run the program again. We have to cheese this. One sec. Okay, this is cheesy. If the user does something wrong, the program should not exit and force the user to restart it to do the right thing again. Really, we would want to present the menu again, present the same set of choices, and give the user a chance to enter in the correct input, because they screwed up. They didn't enter 1, They didn't enter 2. They didn't enter 3. They didn't enter 4. This is explicitly saying they did not enter 4. If they did not, say it's invalid, run the program again, etc. So the question then is, let's return 0. What happens if they do enter 4? Well, nothing really. It's just going to exit gracefully. If they do enter 4, it's not equal to 1, not equal to 2, not equal to 3. It is 4, so this will not run. And instead, the program will just exit. Again, it's kind of clever how they chose to do this. Let's give it a test. Let's test it with the book's input. Here's our wonderful menu. Choice is 3. How many months is 4? Charges are $400. Invalid input. Let's see what happens when I do use the number 4. Exits the program like we would expect. If that doesn't make sense to you, pause the video here and go back and walk through this step by step, particularly for when the input is equal to 4. Take it through step by step, check by check, and make sure it makes sense why we're not seeing any output if the result, or if the input from the user is 4. Oops. Okay. Oh, hello, Visual Studio Code. Little Python program I was working on. All right, 188. Yeah, nested if statements. Okay, this is good. Let's hit the slide first. There we go. A nested if statement. An if statement that is part of the if or else or part of another if statement. Yes, basically, it's an if statement inside of an if statement. So check it out. This can be used to evaluate greater than one data item or to test more than one condition. If score is less than or equal to 100, if that is true, go into this body of this if and run another if. If score is greater than or equal is greater than 90, grade is equal to the letter A. Let's do a hands-on. I think we'll just step through this instead of coding it all from scratch. So we've got a char called employed, and the comment says, so the point of this variable is to track if the user is currently employed, Y or N. Similarly, a char called recent college grad, Y or N. Okay. Answer the following questions with either a Y for yes or an N for no. Are you employed? We see in to employed. Have you graduated from college in the past 2 years? We see in to recent grad. Determine the applicant's load and qualifications. So if they are employed, if they've entered, notice it's capital Y. We've prompted them for capital Y. Lowercase y would not count here. If they are employed, if that is true, enter into this next if-else structure. So if they are employed, yes. If they are also a recent grad, yes. You qualify for the special interest rate. Otherwise, you must have graduated from college in the past 2 years to qualify for the special interest rate. So if they're employed, but they're not a recent grad, this else runs. Else, so this is the is employed kind of branch. Else, we scold the user and say you must be employed to qualify for the special interest rate. You can see the prompts here. Are you employed? No. Have you graduated from college? Yes. You must be employed. So notice how if they are not employed, they don't even get the recent grad question. It's like, who cares if you're a recent college graduate? If you don't have a job, you're not getting that rate. Little Johnny or Susie. That's the gist of your nested if statement. This is a good graphic here, actually. Keeping track of which if and else and if else, if else, go together can be challenging. Luckily, we have an IDE to help us with this. But you can see from the graphic here, too. I'll show you in the IDE in a second, but from the graphic, they're pointing it out with arrows. So this if and this else go together. And then the outer if and the outer else also go together. We can keep track of that in our IDE quite simply, and you've probably seen it so far. So if I put my cursor right before the opening curly, it highlights the corresponding closing curly. So I could jump in here and say something like if 1 is equal to 2, cout cool. This is meaningless. I'm just trying to show you the syntax highlighting. Else if 0 is less than 10, cout. This is about as creative as I am with my coding examples on the fly. Okay, so here's a nested if. Again, the IDE will keep track of the curly braces for us. So we know, there. This closing curly is a part of this opening curly. This closing curly is a part of this opening. Similarly for the outer if and else if. Okay, so use your IDE to your advantage. Also highlights the parens for us, even up to this level in int main. Does not highlight the angle brackets. That's okay. Notes on coding nested ifs. So an else matches the nearest previous if that does not have an else. That it sounds way more confusing than it actually is. And proper indentation aids comprehension. And again, our IDE Visual Studio will help us with this. So if score is less than 100, okay, so say our score is less than 100. If score is greater than 90, the grade becomes an A, else, blah, blah, blah. So this goes with the second if, not the first one. Just use curly braces. That's my final word on that. All right, logical operators. So when we use expressions to ask questions, we say things like are two things equal, is one thing less than another thing, but we can also use the words and, or, and not. So in C++, the syntax for and is 2 ampersands. The syntax for or is 2, these are called vertical pipes. On my keyboard, that key is located right underneath the backspace key, right above the enter key, and it is shift on that key. It's called a vertical pipe. Not is represented with a single exclamation point. I will caution you, a single ampersand sign and a single vertical pipe in C++ means something quite different than and or. So always use the double ampersand and the double vertical pipe if you're saying and or. So new relational expression is true if both expressions are true, or is true if either of them are true, and not simply flips. If something is true, it becomes false. If something is false, it becomes true. Examples are key with understanding these logical operators. So here we have some variables. So x is equal to 12, y is equal to 5, z is equal to -4. Let's see how these new logical operators come into play. So we have an and here, and we also have parens. So from our order of operations, we're going to do what's in the parens first. So what do we have here? 12 is greater than 5. Yes, that is true. 12 is greater than 5, and 5 is greater than -4. That is also true. So this guy is true, and this guy is true. So the result of this expression is true. Let's try again. 12 is greater than 5. That is true. And -4 is greater than 5. That is false. So this whole thing becomes false. Okay, in order for an and to be true, both things must be true. Because one of these is false, the whole thing is false. It's kind of the opposite with the or. So here we have 12 less than or equal to -4. Is 12 less than or equal to -4? No. So that is false. Or, let's see what we got here. Y. Is 5 equal to -4? No. Both of those are false, so the whole thing becomes false. Is 12 less than or equal to -4? No. Or is y, 5, not equal to -4? So this is actually true. Y is not equal to, or 5 is not equal to -4. That is true. So because one of these is true, the whole thing is true. That's the OR. Finally, let's see, 12 greater than or equal to -4. That is true. What is inside of the parens is true. However, we have this not hanging out here that makes it false. That flips the true to false. To recap, with an AND, both sides of the AND have to be true for the expression to be true. If one of them is false, the whole thing becomes false. With OR, both of them have to be false to be false. If one of them is true, then the whole thing becomes true. With the NOT operator, it simply flips whatever the result currently is. So if something is true, not true is false, not false is true. That needs to make sense in order for you to continue on with this lesson. So if it doesn't make sense, rewind the video and give it another listen. Okay, let's do a hands-on. 192. There's that table again for you. Let's do it. 4-12. All right, we've got char, employed, and recent grad. Cout, are you employed? Cn, employed. Cout, have you graduated? Whatever. Cn, recent grad. Okay. If employed is equal to the uppercase letter Y and recent grad is equal to uppercase letter Y. So notice the double ampersand. Cout, you qualify. Else, Cout, you don't qualify. Okay, so you can see how we combined. In the previous example we looked at, we had to do this with a nested if. Because we now have the ability to chain these expressions together, we don't have to have the if and the nested if. We can say the whole question on a single expression. So if both of these are true, we qualify. If only one of them is true, because we're dealing with an AND, we don't qualify. Okay, logical operators in the bool variables. So logical operators can be used with bool as well as expressions that evaluate true or false. Example, bool done equals false. If, here we go. These can get quite challenging. If not done. So if not false and count is less than 6, do a thing. So if not false, so if true, and if count is less than 6, do a thing. We don't know the actual result of this because we don't know what count is. Let's take a look at least at some hands-ons. I know we're getting a little lengthy here on time. I try to keep these videos to around 1.5 hours to 2 hours. So let's take a look at page 194. So we have some constants here, min income and min years. We have the presumably inputs for income and years. We get those values from the user. If income is greater than or equal to minimum income or years is greater than min years, you qualify for the loan. So here they're giving them a choice. Previous example, they had to be employed and a recent grad to get the special loan rate. In this case, if their income is greater than the min income, or whatever years at current job, is greater than the minimum years, then they get the special loan. So in this case, only one of these has to be true. If both of them are true, then certainly they'll get the special rate. But only one of them has to be true. And if neither of them are true, that is when the else will go ahead and fire. You can run through some of the example inputs, see the outputs. Here's 414. Demonstrates whether or not an applicant qualifies for a loan using the not logical operator to reverse the logic of the if statement. Don't do it this way. This gets confusing. Okay, so why make it more complicated than necessary? Our last example is perfectly fine. It's basically the same example, only with different logical operators. So if income is greater than min income, or years is greater than min years, not that, then C out. So if you look carefully, if you flip back to the other one, the if in the previous example was used to determine if they qualify for a loan. In this case, the if is being used to check if they don't qualify for a loan. The not is what is doing that for us. I'll say that again. The previous example, the if statement conditions were checking to see if we are qualified for a loan. In this case, our if condition, because of the presence of this not operator, checks to see if we are not qualified for the loan. So if this becomes true, we're not qualified, otherwise we are qualified. Definitely prefer the first example. It's much clearer. Okay. Illustrates what can happen when a Boolean is compared to the C++ constant true. Yeah, let's actually do this one. This one's kind of cool. 415. This one has some good, useful stuff. Let's include IOStream. Let's include CC type. Cout is question mark an alphabetic character. Here's the reason why I wanted to show you this. Cout, built-in C++ function we get from CC type called is alpha question mark. So that can be helpful when checking user input. We can see if what they've input is an alphanumeric character. Let's copy and paste. How about is capital X is lowercase x, capital X, lowercase x. If is alpha x, some fireworks going on outside, equals true, else let's do the same thing. Only we'll do it like this. Omit the equals true. Let's make this our startup project. This is 15. Run it. We need new lines. Okay, so is question mark an alphabetic character? No, it is not. Is capital X an alphabetic character? Yes, it is. Is lowercase x an alphabetic character too? Huh? Let me see no and yes. So let's pull this down. 2. I'm going to double check my input. Yeah, okay. So in line 14, when the condition is alpha lowercase x equals true is tested, the program did not produce the desired result. The value 2 returned by is alpha was compared to the value 1. So the condition evaluated to false, even though in fact both values represented true. Code in line 20 worked correctly because the value 2 returned by the is alpha function was correctly interpreted as true. All right, cool. I'm going to skip over the short circuit business. I'll mention it. Okay. But I'm going to talk about it in the context of a previous example. It's one of those kind of goes without saying type of things, but let's see. Let's hop back. One more. I want to look at an and, actually. Yeah, this one. This would be a good one. Okay, short circuit. What that means, in this expression, we have is employed yes and recent grad yes. Both of those things have to be true for this whole expression to be true. We know that. We've been over that before. So what we can assume, I'll ask you, what can we assume that if employed is equal to n, the whole thing must be false? We don't even need to check the second expression here. If employed is not equal to y, this whole thing, we know that's going to be false. All this short circuit slide is talking about is the fact that the C++ runtime does not need to check the second condition. If this first thing is false because of the and, we don't even need to worry about the second one. All right, logical precedence. More logical precedence. Highest is not, then ampersand, then or. So this whole thing is true because and is evaluated before or. So we're actually doing this first. Again, if in doubt, use parens. I would definitely use parens in this case because I would have not have remembered that and comes before or. I would not necessarily expect you guys to remember that either. So use parens. Okay, so this whole thing is true again because and is evaluated for or. So is 5 greater than 6? No. Is 7 greater than 8? No. So this whole thing is false. Is 2 less than 3? Yes, that is true. So now we have true or false. Because it's an or, one of them is true, the whole thing is true. We can talk about validating some numerical ranges here, used to test if a value is within a range. If greater is greater than or equal to 0 and it's less than or equal to 100, we can say that it's a valid age. We can also see if it's outside of a range. So this is like testing to see if a grade is valid. This is testing to see if a grade is invalid. You cannot use mathematical notation. Don't do this. This is something you'd see in like an algebra class. You can't do this. You have to say it one of these other two ways. Okay, so we have these range checking methods, and so we can start to validate user input. We can inspect input data to determine if it's acceptable. We want to avoid accepting bad input because we don't always code for bad input. We might have unpredictable results. We can test on ranges, reasonableness, valid menu choices, and 0 as a divisor, as we've seen before. Let's check it out, page 201. All right. Again, this is kind of one we'll just talk through a little bit. So we have our constants for grades. We've got min score 0, max score is 100. An input that's going to accept a test score. So we're going to test to see if the input itself is valid. So before we start testing the individual scores, we're going to test to see if the score that was entered is within the range of acceptable scores. So is test score greater than or equal to min score, greater than or equal to 0, and is it less than or equal to max score? Notice they both use the equal sign. So if one of these is false, if it's either less than the min or greater than the max, then this whole thing fails and we move on to presumably an error message. If both these are true, then we move into the inner if-else if and start to check the individual grades. Yes, and there's the else with the invalid score. Blocks and scope. The scope of a variable is in the block, which it is defined from the point of definition to the end of the block. Variable is usually defined at the beginning of a function. They may instead be defined close to the place where they are first used. Variables defined inside of curlies have local or block scope. When in a block that is nested inside of another block, you can define variables within the same name as the outer block, so you can reuse variable names in this instance. Sort of a very specific instance. When the program's executing in the inner block, the outer definition is not available. Generally not a good idea. The program is hard to read, hard to understand. Let's check out page 203. Probably notice I'm trying to pick up the pace a little bit here. Picking out the main points in some of these programs. Okay, the program determines whether or not an application qualifies for a loan. We've got our consts here, minimum income and minimum years. We're prompting for income. If income is greater than or equal to min income, we say income is high enough, so get your years at the current job, then input current years. If years is greater than min years, we qualify. Otherwise, we show an error message. If the income doesn't fit, if the income doesn't fall within that range, then we go ahead and just run the else, and this whole thing is ignored. Cool. Okay, here's an example of scope where we're using two variables with the same name. Interesting. So we've got an int number up here. We've got an int number in here. I would consider this bad programming style, but it does demonstrate scope. Okay, so when the program enters in this block, this int number sort of takes over. Outside of this block, this int number is what counts. Okay, more about characters and strings. So this is going to get into some more input validation. So you can use relational operators with characters and string objects. So if menu choice equals the character A, or if name1 is greater than or equal to name2. And when you're comparing characters like this, you're really comparing the ASCII values, which we saw before, which we know that, for example, the integer ASCII value for the uppercase letter A is 65. So when you're doing these comparisons, you're really comparing those ASCII values behind the scenes. Comparing string objects is comparing the ASCII values of the characters in the string. So if we say, is first name equal to last name, and those are both strings, you're comparing the individual letters inside of the strings. Comparison is character by character, starting with the first character of each string. We saw this already. This is a good little library of built-in C++ functions that you can use to validate user input. Things like isAlpha returns true if it's a letter, false otherwise. Is alphanumeric if the argument or if the input is a letter or digit, false otherwise. Is digit, that's a good one if you're testing for like integer data. This will test if it's a lowercase letter. This is all documented in your textbook. Is print is a printable character. Is punct I wasn't aware of that one. That one's new to me. Is upper, not I supper, is upper true if the argument is an uppercase letter? Is it a space? Good stuff here. I suspect that these examples are going to be fairly straightforward and similar, so we will just look at them. Yep. So this is good. So enter a digit or a letter. cn.get, another method, remember, of getting user input. Inputting to ch. Determine whether or what the user entered. If it's greater than or equal to the letter 0, or the, how should I say this, the character 0, and it's less than or equal to the character 9, you entered a digit. That's one way to test if it's a digit. Because remember, we're comparing not to these characters, but to the ASCII codes that the character represents. And you could go and find an ASCII table and look and see and verify that digits would fall within this range. If it's greater than uppercase A, less than or equal to lowercase z, you entered an uppercase letter. Same thing with lowercase. Alrighty. $208. Cool. Price A, price B, we've got some consts. We've got some input for a part num. So we got a big prompt here. We see into part num. And here we set some output parameters. We're testing to see, is part num equal to the string this, or is part num equal to the string this? We print the price of that part. Else if part num is this or part num is this, print out the price for that thing. I will say that this is a bad way to test for this kind of input. You generally don't want to do string comparison in this way. There are better ways to do this type of string comparison that are kind of outside the scope of this class. This is okay for demonstrating the concept, but in a real world enterprise level application, there are much better ways to compare strings than just using the double equal sign. Here's a bunch of examples of the is functions that we just looked at. Feel free to play with that if you want to get some practice with those. Yes, the conditional operator. Okay, this is a hotly debated topic in a variety of programming languages, and I used to hate it. I used to tell my students that I hated it, and then I started using it a lot in C# programming, and I actually kind of like it now. It basically is a quick shorthand way of creating an if-else statement. Especially useful for short if-else statements. So the format looks like this, and it does look strange because it introduces two new pieces of syntax. It introduces the question mark and the colon key words, I guess. So we test the first expression. This is what it looks like. This is a real example of what it would look like. Is x less than 0? Question mark. That is a question. Think of this as like the question. Is x less than 0? Question mark. If it is, set the value of y equal to 10. Otherwise, which is what the colon means, set the value of z equal to 20. Let's take a look at an example. 213. All right, here's that example. So we're inputting hours, which is a double. So determine how many hours to charge for. So hours equals, so we're going to assign something to hours. Okay, what are we assigning to it? Well, here's the new syntax. We're asking the question, is hours less than min hours? Question mark. Asking the question. If this is true, if hours is less than min hours, assign min hours, the constant, to the variable hours. Otherwise, just keep it as hours. So it's like a built-in inline if statement. It's a quick and dirty way of writing an if statement in a single line. More kind of alternative syntax for things that we've already seen, the switch statement. Uses the value of an integer expression to determine the statements to execute, may sometimes be used instead of if-else-if statements. If you can do it with an if and else if, that's fine. You don't need to use a switch. If you like the switch better, go ahead and use it. I don't care. Personally, I prefer if-else-if. I rarely use the switch statement unless unless it's obvious why I would want to use it. Menus are sort of an obvious example of why a switch would come in handy, but let's take a look at the syntax. Keyword switch, parens, there's an expression here. In the case that expression 1, we run the statement set 1. In the case expression 2, statement set 2, etc., and there is a default case. Let's take a look at an example on page 216. I think this makes more sense than the previous slide. We have a char called choice. We want the user to enter A, B, or C. We cn choice, and we switch on the choice. Okay? Switch on the choice. So we're switching over choice, which is a character. So in the case that choice is the character A, we're going to see out this thing. Notice the colon here. It's a subtle, easy thing to miss. We're going to see out that thing and then break. And then basically the break means exit the switch structure. In the case that choice is B, print you entered B, and then break out of the switch structure. In the case that choice is C, print you entered C, and break out of the switch structure. Otherwise, if none of these other guys were true, if none of these other cases were true, print you did not enter A, B, or C. And then that's the end of the switch. Curly braces. I think they may have missed one. So this curly should be aligned with this opening curly, and there should be another closing curly down here. Okay. Talked about the break statement, stop execution in the current block, exits switch. We'll be using the break statement and its corresponding continue statement. Later on, we get into looping structures. Example switch statement. So another example. In the case that plus or minus is the character plus, print out plus. In the case that it's a minus, print out minus. Otherwise, print out it's an invalid value. Again, pay attention to the colons. These are important. These happen after every case. And as I said, a good context for a switch statement is within a menu. A long list of hands-ons. Let's take a look at some of them. Pointing out the important pieces. So here again, we're prompting for a letter input. In the case that it's A, print out A, B, print out B, etc. Imagine what this would look like with an if and else if structure. It would probably be a lot more code, a lot more curly braces, more parens, just a little more syntax than you get with a switch. So the switch statement in this case probably saves you some typing. Let me go back. Next example, we have an int model num. So we've seen examples with the switch statement and characters. Here's an example with an int. We're switching on model num. So in the case that model num is 300, do this thing. In the case that it's 200, do this thing. In the case that it's 100, do this thing. Otherwise, do that thing. This is kind of cool. This is a little syntactical trick that you can use with the switch statement. It's kind of like an OR, I guess. I never used this, but it's kind of interesting. Here we're prompting for a feed grade, which is going to be a character. In the case that feed grade is lowercase a or uppercase A, print out this thing and break. So basically we're catching two cases here. We're catching a lowercase and an uppercase a. Same thing with B, same thing with C, same thing with the default. It's called, I didn't know this until I kind of looked through the chapter. It's called a fall through feature. Accepts both uppercase and lowercase. Interesting. Here's a kind of a fuller example of a switch with a menu. So very, very similar to what we saw with the if, else, if, only they've switched it up, if you will, to a switch statement. So switching over choice, which is an int, in the case that choice is 1, run this calculation, then that calculation. You'll notice here that we don't see the same repeating of code like we did with our version of this program with the if, else, if. There's no prompting for input multiple times. The only thing that really changes is the calculation. The rest is the same. Almost done. One more concept. I know we're getting long here. Over 2 hours at this point. It's a big chapter. Enumerated data types, or also known as enums or enumerations, is a data type created by the programmer, so it contains a set of named integer constants. That's all it is. It sounds fancy. We've seen all the pieces that make up an enumeration before. It's a set, or like a list, of named integer constants, or it's a list of constants. Format looks like this. This is the syntax. Keyword is enum, the name of the enum, open curly, closing curly, and then values in between. So it's a way of grouping together named constants. So enum fruit could be apple, grape, orange. Notice there's no double quotes. There's no kind of special syntax. You're just naming constants. Good example would be for days, mun to 1/3 fry. That's a great use case for an enum. Difficulty setting in a video game, easy, medium, hard. Enumerated data type variables. To define variables, use the enumerated data type name. So fruit, snack, days, workday, vacation day. A variable may contain any valid value for the data type. So this is how we create our own variable using the enum. So back here, we had an enum called fruit. Here's the type of data. Just like we would say int month, we can say fruit, that data type we created, called snack. We can have days, which is the name of an enum back here. One called workday, one called vacation day. And then we can assign snack to orange, for example. Again, no quotes. And then you can compare with them. If workday equals wed, do some set of statements. That's used in a conditional. All right. Behind the scenes, I said that enums were a set of named integer constants. Here's where the integer thing comes in. Behind the scenes, when we created that fruit enum, behind the scenes, apple actually is the value 0. Grape actually is the value 1. Orange is actually the value 2. So whenever in your code you're assigning apple, you're really assigning 0. Named integer constants. It makes a lot more sense to us reading our code to say apple and know what that means instead of seeing the number 0 and guessing what that means. You can override the default association so you don't have to start at 0 and increment by 1. You can start wherever you want and increment by whatever you want with this sort of syntax. Then you can test. You can compare them to their integer values. So if snack equals 1, you cannot assign them using their integer values. So snack cannot equal the number 2. Snack has to equal one of the defined enum values, apple, grape, or orange, or whatever our list of valid snacks are. Greatly improves the readability of a program. Enumerated variables cannot be used with input. They only display the name associated with the value of an enumerated data type if used with cout. Let's just take a look at an example so we can say we've done one. 227. Here's an enumeration. Maybe I skipped ahead one. 226? Yeah. Here you go. So we've got our enum up here called roster. Looks like a bunch of names. We're saying Tom behind the scenes is going to mean 1. Sharon, Bill, Teresa, and John are going to increment by 1 after the number 1. So John will be assigned the default value. Sharon through John will be assigned 2 through 5. So Tom is 1, 2, 3, 4, 5. Then we can switch on who. So we've got an int called who. You can see into who. We just said that you couldn't see into an enum, but who is just an int. And then we can switch on that int to see if who is equal to Tom, which behind the scenes is number 1, or Sharon, which behind the scenes is number 2, etc. If that doesn't make sense, rewind and watch that again, because it's actually pretty cool that we can compare two names now, named constants, instead of arbitrary integers. It's much more clear to switch on who and say case Tom than it is to say case 1, case 2, case 3, 4, 5, etc. Good stuff. Enums are used all the time in the real world. I have like probably dozens, I would say, of enums in my code that I work on in my day job. Let's take a quick look at the case study and the tying it all together example, and then we'll call it a lesson. 229. Okay, another of the services provided by landscaping is the sale of evergreen trees, which are priced by height. Customers have the choice of purchasing a tree on a cash and carry basis, purchasing a tree and having it delivered, or of purchasing a tree and having it both delivered and planted. How convenient. The table shows the price of each of these choices. We need to build a program that uses the number of trees purchased, their height, and the delivery and planting information to create a customer invoice. Simplify the program, you may assume that all trees purchased by a customer are the same height. Here's basically our parameters. This is what would be given to us by the company that's asking for this program. We can start creating like an English set of steps that we would use to solve the problem. So must carry out the following general steps. User inputs the number of trees purchased and their height. Have the user indicate if the trees will be planted by greenfields or not. If that service is not desired, have the user indicate that if delivery is wanted. Calculate total tree cost, calculate planting and delivery charges, calculate total of all charges, and then finally display all that information nicely to the command line. Thinking about it, we have our named constants. This is never something I would like write down separately outside of my program. It would be something I would jump in and actually start coding. Here's some good pseudocode. Initialize everything. Display the screen heading, maybe a prompt. Input num trees, height, and planted. And go through. Let's take a look at the code. Here's our constants up at the top. And our variables. Here's our prompt. Input the number of trees purchased. Input the height. Do you want the company to do the planting? Yes or no? Here we're doing some input validation. If it's not planted, yes, uppercase or lowercase. Do you want the tree delivered? Yes or no? Calculate the costs. If the height is less than 3, associate that tree cost with the const price 1, etc. Here we're calculating the total tree cost. Doing some checking on if they want it planted or not. Using some nested if and else if. And here's kind of something interesting. They have a comment. They commented out the else. That's because this particular else isn't necessary, but they still put it in there as a comment for clarity and emphasis. Finally, we do a calculation of the total charges. And on the next screen, we spend some time. There's no way I would retype that, outputting the invoice to the user. might look something like this. Crazy Al's Computer Emporium case study. Tying it all together. A fortune teller. With the RAND function you learned about and the if-else statement you learned about, you can now create a simple fortune-telling game. Your program will start by asking users to enter 3 careers they would like to have someday. The program then uses the random numbers to predict their future. Okay, so remember with random numbers, so this is the variable that will actually hold the randomly generated integer. We seed the random generator so that we get a different random number every time the program is run. We usually seed it with the current timestamp. We seed the random, prompt the user, do you want to be a, oh, here's some examples. Chef, astronaut, CIA agent. What's the difference? So get your career choices 1, 2, and 3 using getLine. Randomly generate an integer. So here's your random range between 1 and 4. That syntax we talked about in the last lesson. Use branching logic to output the prediction. So if it's 1, you'll be a this. 2, you'll be a that. Otherwise, well, something went wrong. You're not going to be any of those. And here's a sample run through. Okay, big chapter here. Lots of information. As a reminder, this lesson will go up in the Pages section of Canvas under Chapter 4. There is an associated assignment, which at the time of this video is not actually published yet. I'm trying to record these early, get a backlog of them so I can slowly release them, like I was saying, every week. So that does it for Chapter 4. I believe the next chapter will be getting into looping, which definitely relies on the stuff that we talked about in this chapter, the and, the or, the conditionals, some of the decision-making structures. So as always, let me know if you have any questions. Feel free to pop into the discussion when it becomes available. Debate and discuss topics. And we'll see you right here for the next lesson. Thanks.